All right, good morning, guys. Hey, welcome back. Today is Friday, April 24th. We're gonna get started here with our new math stuff. Make sure you're checking your calendar. That's the pacing that all three of us teachers are gonna be using for a lot of our instruction, for our videos we're gonna post, as well as to help you stay with us and not fall behind, things like that. Not the goal is to not overload you today. We're gonna do some things together. There's times throughout the video I'm gonna tell you to pause the video, and that gives you a chance to work because I'm not gonna sit there and give long pauses where you could be working. It's super important that you actually do some work on your own, not just wait for me to move the video on. Pause it so you can do thinking because that's how we learn, right? You know that, I know that. Okay, so the idea is that if you pause it, do a little bit of work, figure out how to do the problem the best you can, especially on the try it problems. You do the best you can, just like we would in class. I don't just spoon feed you. You need to do a little bit of work on your own end. And so try the best you can to work the problem. Then I will go through the problem. Then you want to check your work, adjust it as I adjust it, and and to see what you learned, right? Then you can actually do some real learning because you can compare it. But if you just wait for me to do it and then you just copy it, you're not really going to be learning very much. You know, that trial and error, that those attempts to learn are so critical. Okay. Before we get started here, this day in history, we haven't done that in a while. This day in history, in 1800, on April 24th, 1800, the Library of Congress was founded. And so Library of Congress is just that. You know, it's in Washington, D.C., and it's a giant library, governmental library, basically. And it's pretty cool. It's actually, I know somebody that works there. She and I taught in Japan at the same time. And my class would know that we talked about how we sent books. I sent books to Japan to rebuild a library at a school that was devastated by the tsunami some years ago now. And she was actually the one. She's uh, basically a librarian. She works in the biggest, awesomest library in the United States. So pretty cool stuff. In 1990, the space shuttle Discovery, it took off and blasted off for space. And what it was bringing to space was the Hubble Space Telescope. Highly recommend you guys look up some Hubble Space Telescope pictures if you've never seen them. They are amazing and allows us to see across uh, the rest of the universe, galaxy, whatever. All right, let's get started with some math here. Okay, let's look at our problem here. Well, first of all, let's go ahead and look at our learning target. Now, this learning target isn't as specific as I want it to be. It's a really generic, broad one, but it still works. This is the standard we're going to be working with. You guys will know that when we left school, with Ms. Studemeyer and I working together when she was doing her student teaching, we just got done doing multiplication of decimals, right? So now we're going to be moving into decimals, dividing decimals. And so our learning target is going to be focused on this bold area. So basically I can divide decimals to the hundredths using concrete models or drawings and strategies based on place value, properties of operations, and the relationship between addition and subtraction. Relate the strategies to written methods and explain reasoning. In a nutshell, I can divide decimals using models. I can explain how I did it, right? And I can use other operations besides division to understand and solve for division. If you guys think back to when we just did normal division, just dividing whole numbers, often we talked about using other operations, not just division strategies, because they're just faster and easier often. So, all right, so let's look at this problem together here. Good. Let's see here. It says, Mr. Kovich is preparing materials for a craft project. He needs to cut 2 meters of string into pieces that are 0.2 or 2/10 meter long. How many 2/10 meter long pieces can he cut from 2 meters of string? So first of all, like we always do, let's go ahead and underline some things that are important here, okay? So number one, okay, he's gonna cut, so he has a 2 meter piece of string, right? Okay, and he's going to cut that. He's going to cut that into pieces, right? he's going to cut these. I'm going to connect this. He's going to cut into pieces this 2-meter piece of string, right? And those pieces there, those are going to be 2/10 of a meter long. Okay, so our question is, how many of those pieces, those 2/10 pieces, can he cut? So we want to figure out how many he has. Okay, so now some of you might be like, oh, I don't know how to divide decimals. Well, problem solve, think, don't flip ahead in your book, challenge yourself. If you mess up on this, big deal. We've talked about this, right? It's part of the learning experience. And parents, that's part of the learning experience that your kid knows how to do. We've been doing all year long. So don't let them bail themselves out by just moving ahead. Have them slow down, have them try. That's why it's called the try it. Try to do this part. Then after they try that, and especially if there's a parent or a sibling or someone, explain what you thought about it. And if you're wrong, big deal. Okay, it doesn't make you stupid or anything like that, like some of you guys beat yourselves up over. It's not that at all. Trying is what allows us to make those mistakes. Making those mistakes allows us to adjust, and those adjustments help us learn. We know this. This is fact. Okay. So now is the time. Now is the time. Pause your video. No, seriously, pause your video. I know you didn't pause your video. Pause it. Do the work. Okay. Oh, thank you. Good. Hey, we're back. Thank you for pausing your video. All right. So let's look at this together then. We can look at this a couple different ways. And so we want to use a model here to try to make some sense of it. All right. So what I'm going to do is I'm going to kind of use a number line here. Use a number line. Okay, my number line doesn't need to be beautiful and perfectly spaced out and things like that. Now the idea is I'm going to treat this whole number line here. It's not just going to be my number line. It's actually going to be my 2-meter string. This is going to be my string. Okay. So we're going to say the string is from here is 0. From here is 2, right? Because we have 2 meters. So somewhere in the middle here is going to be 1, right? Okay. Again, I'm going to stop here for a second and say, if you didn't pause your video, you didn't try it yet, this should get you started. You're like, oh, I really didn't know how to start. Now would be a good time to pause it and complete what I've started the best you can. That would be the best thing to do right now. Okay. And back. All right, here we go. So what I'm going to do here is, the idea is I'm dividing this into pieces that are 2/10 long. Okay, how can I do that? Well, can't I just count up by 2/10? That makes sense, right? We're comfortable with tenths. We've been doing all year. We've been adding decimals. So if I go ahead and just use this and create like a number line, if I go ahead and maybe put it about here, I write that this is 2/10, right? And then I skip count. So if that's 2/10, then I go up 2/10 more. This would be now 4/10, right? That makes sense, right? So this is be plus 2/10 essentially, plus 2/10, right? And I can keep doing this. Let's say that's 0.6, 0.8, and this would be 1, right? So the idea is if I cut this rope in half into 1-meter pieces, I can see that I have 1, 2, 3, 4, 5 jumps there because I have 1, 2, 3, 4, 5 pieces, right? So I just cut 1 meter into 5 parts, right? Cut 1 meter into 5 parts. So I'm pretty sure that if I continue cutting it like this, I should get the same amount on this side, right? Because if this is a meter, this is a meter, it should work out, right? So let's go to keep cutting here. So from 1, I'm going to go and cut. This is going to be now at what mark? Say it out loud. I can't hear you. Good. 1.2, right? Okay. 1.4. And let's just keep going. 1.6. 1.8. And then 2, right? So we're just adding 2/10 each time. Again, if we think about what you guys just did in your math books for a lot of our patterns and things like that. There's a lot of skip counting. This is just skip counting by 2/10. So we're just looking at it as a skip counting by 2, but it's just 2/10 instead of 2 ones or whatever, right? So again, if there are a total of 5 jumps, there's 5 pieces on this side. Pieces. There's 5 pieces on this side, right? And guess what? There's 1, 2, 3, 4. What do you know? There's 5 on this side too. There's 5 pieces over here too, right? Okay, for a total of, obviously, right? So there's 10. Ooh, I shot this. There are 10.2 meter pieces. Cool. So we just, by the way, we just divided decimals. Pretty cool. I know. Let's think about this in a slightly different way now. That's one way you can think about it. It's a model to make sense of it. Let's think about this because you might have used a different strategy. And I might not share your strategy. You might have got some of, there's other ways, there's lots of ways to think of this. But often when we talk about any operation, but especially division, we talk about using the, say it, what do you think I'm going to say? The inverse operation. The inverse operation, as you know, is what? The inverse operation of division, I should say. The inverse operation of division is, Molly, you should be saying it right now. Multiplication, correct? Beautiful. So in this problem, if I'm going to use a different color here, okay? In this problem, if we think about this, what we're doing is we're taking 2 meters, right? We're taking 2 meters, right? And we're dividing this. We're dividing this into groups of. We're dividing this into groups of 0.2 meters, right? And that is what we're trying to ultimately solve, right? So we're looking at 2 meters divided by 2/10 of a meter. Well, again, let us think about inverse operations. How can I write this equation so that the inverse operation is being used? Go ahead and do it if you haven't done it yet. So we know it's going to be multiplication, right? Well, let's just review real fast some something basic here. So if I say that, let's just use a simple number like whole numbers too. Let's say that 6 divided by 2 equals 3. We know this. 6 divided by 2 equals 3. You know this. I know this. Your dog knows this. We all know this. Okay. We've done this before. You've done this before. Okay. The inverse of this would be saying that 2 times blank equals 6, right? So we would know then that that 3 would go here. It's a fact family, right? So the same thing would be here. Okay. This is my dividend. My dividend, like we talked about in class, my dividend is going to become my product. My product is the answer I get when I multiply, right? Okay, so my dividend, I'm going to use a different color here to kind of correlate it. That's going to end up there, right? And then the divisor is going to end up being one of these. It doesn't matter which one, so I'm going to put a line for either one. It could be either one of those, right? And then let's use this blue. This blue is, no, let's use green. Let's use this green. This is my quotient. My quotient is either going to be one of those as well. It could be either one is the point. So the idea here is that my factors, these are my factors, okay? The factors are interchangeable when we multiply. It doesn't matter the order that we multiply in, as you remember. If not, it's a nice little review for you to hear because you probably haven't heard it in a little while. It doesn't matter the order it is to get our product, right? So we have factors and products. So the idea is if we just match the colors up, again, these don't matter which order they're in. So I'm just going to go ahead and put 0.2 here. from that, I'm going to put the question mark here. And then I'm over here, I'm going to look at this as the 2, because that is the same. This is my product. That's my dividend. So the idea is my mental thought process is 2/10 times what equals 2? Have you done that this year? Have you done that this year? Yeah, we've done that this year. We've thought about this before because in this problem, now this is our introduction problem, so it's not a super difficult introduction problem. The numbers, as far as numbers go, the values and things like that, because it's 2/10 and 2 here that we're dealing with, so it keeps it really relatable. But the idea is that if we know that, think about multiplication, we know that if 2/10 times what it gets us to 2, well, this is getting larger from 2/10 to 2. It's getting larger by how much? Good. One place value, like some of you I know said, and some of you might have said, well, it's getting larger. Well, it's getting 10 times larger, right? Okay. So we're multiplying by 10. And well, that would confirm our answer here too. 10 times, right? There'd be 10 of them. It'd be the same thing here. So we know that the question mark would be equal to 10, correct? Okay. So yeah, let's keep moving on. So that was good practice there. Hopefully that's making sense. Obviously, you can pause the video at any time if you want to adjust things. Pause, stop, and fix it. Work at your pace that works well for you, okay? All right, let's go on the next page here. Okay, so again, number 1 says, look back, explain how you found how many 2/10 meter pieces are in 2 meters of string. This is where you think about what you did, and then you think about even what I did, if you adjusted it, then write what happened. Write what happened. I'm not going to write an answer for this one because I just explained, I just went through what I just said, right? But you writing it is really important because it's you showing that, oh, I understand what Mr. Smotchus was saying in the video. I understand what I did, and I can explain what I did. So go ahead and pause the video right now and go ahead and write your answer for that. Again, I'm not going to wait here, so pause. Okay, now I'm going to continue with the next part, okay, but you should have written that. So thank you for those of your following expectations and doing that. Number 2, it says, you can look for patterns in division to see how dividing with whole numbers and dividing with decimals is alike and different. Complete the quotients in the table to see patterns in division. So naturally, if we're going to 2 divided by 2, how many groups of 2 are there in 2? Well, obviously there is 1, right? Okay, there's 1 group of 2 in 2. Okay, 2 divided by 2 is 2. Just like anything divided by the same thing is going to be 1, right? So 2 divided by 2 is 1, right? Okay, now let's think about this though. Okay, how many groups of 2/10 are in 2? Well, we just did this problem. That was what we just did on the other page. 2 divided by 2/10. That's the problem we just did. So we know the answer is 10, don't we? Okay, hopefully you're seeing a pattern emerging. Wow, this is weird. It's just like we talked about when we multiplied by powers of 10, right? Or when we multiplied by anything in the past, we talked about how we can see patterns emerging, things like this. And again, what's changing here, the 2 isn't changing, right? But so the dividend isn't changing, but the divisor is changing. And each time it changes, it's changing by a factor of 10, right? So it's adjusting by 1 power of 10, correct? So the idea is that how many groups of 200s are there in 2? Well, if there was 1 in 2, and there was 1 group of 2 in 2, and there was 10 groups of 2/10 in 2, then there should be 100 groups of 200s in 2, right? So the idea is that you're like, oh, Mr. Munch, how's that number getting bigger? What's going on here? Think about this. If we cut things up into a smaller piece, right? If I have this pin here, okay, and I cut this pin in just in half, I'd have 2 parts, right? Cut it in half. Now I have 2 pieces, don't I? Okay, but so that would be dividing into 2 parts, right? But if I cut that into smaller pieces, if I divide that into much, much smaller pieces, I'm going to have more pieces. Okay, just because that number is larger, that number is just telling me how many pieces I have, right? Okay, so a lot of times kids get confused with division, that, that my number needs to get smaller. Hey, if I divide 6 divided by 3, I get 2. The number is getting smaller. Well, that's because I'm dividing into groups of 3, right? Okay, or the value of the group is 3, right? Okay, but here I'm dividing by a value that's less than a whole, right? So if I divide by something that's less than a whole, that means the amount I'm getting is going to be a lot bigger. Think about money, right? If you think about money, it makes a lot more sense as well. If I have $2 and I divide this into groups of 2 pennies, 2 cents, right? Here's 2 pennies. Here's 2 pennies. And I have 100 pennies, that's $1, right? I separate those out into the groups of 2 pennies each, and I have $2. Well, naturally, I'm gonna have 100 groups, because in $1 there's 100 pennies, and $2 and they're in 2 penny groups. It's gonna be 100 groups, isn't it? Okay, so again, hopefully this is help it make sense. The whole goal with this lesson today is making sense and building on that concepts for you. Okay, so let's keep going here, so this video doesn't get too long. So again, using this next pattern here, use the pattern, division pattern in the table to compare the equations. Again, this is what we just did. Okay, exactly the same thing we just wrote here. So it's going to be 2 divided by 2 is 1, 10, and that's 100. Okay, it's the same exact thing that we're saying there. Okay. How does the quotient compare to the dividend when the divisor is greater than 1, when the divisor is less than 1? Well, that's kind of like we just talked about, right? Okay. So go ahead and write your answer for that, because I literally just talked about that. If you need to pause it, do that. Go ahead and do that, and then we'll move on. Okay. I'm not worried about this one necessarily right now. Okay. Because of time and for the video. Okay. You can do that on your own later. Okay. Okay. Next, this section here, I'm actually going to give you. I'm going to give you some examples. You can write your own examples. Obviously, be creative with your own examples. But I'm going to give you examples right here. Now would be a good time to pause the video and write this, because I'm only going to leave this on here for like another second here. So pause the video, write these down. You don't have to use these examples. You can use whatever examples you want. And I'm going to tell you also, you don't have to write all of these examples. Let's say if you write 3 or 4 of them, you're good. Okay, that's my expectation. 3 or 4 examples and you're good. Okay. Right. Obviously, if you're not watching the video, then you're going to be doing all of them, but benefits of watching the video, I guess. Okay. All right. So again, that should have been paused. And so I'm not going to write anything in there. There's no reason for me to write anything there. You just saw all the good information. Okay, that's just a review. That's just a review of inverse operations. So it should be nice. But the idea is that these inverse operations were connected to a multiple, as you saw with the examples, many different examples, whether they are multiplication, division of whole numbers, whether it's multiplication, division of decimals, a lot of different ways to look at and model it. So let's look at the bottom here. It says, write a related multiplication equation for the division equation 5 divided by 2/10 equals n. I want you to do this on your own. Pause the video and do it on your own. Okay, good. Now we're back. Again, if you thought about, hopefully you paused the video and you thought about how do we do this? We already did this, right, on the previous pages. So how do we do this? So the idea is that, again, that 5 is my dividend. That's going to become my product, right? So the idea would be 0.2 times n equals 5. Correct? Okay, perfect. Yeah, we don't need to solve that right now. It's just, that's just what it's asking us to do. Okay. All right, last page, this last one thing we're doing today, yo. Okay. And I actually want you to do it on your own. I'm not going to write an answer for this one. This is 100% you to finish this up. If you have questions about this, I'll be in the Google Meet for math support at noon today, from noon to, maybe not noon, maybe a little bit after. I have a staff meeting at 11:30, so I'm going to try to be on there at noon, but it might be 12:30. Okay, but I'll try to be on there as soon as possible. I'm only going to be on for an hour today. I have a lot of other work I got to catch up on with all this new stuff that's rolling out. So roughly 12:30, just check Google Classroom. I apologize for that. It's going to be a little bit iffy. I'll be on there for about an hour to an hour and a half today. So do this. If you need help, want to get checked out, see me at that time. All right, guys, talk to you later.